Hi Bobcats, this is Miss Lee, and today's video lesson is on equations from situations, more specifically writing one-step and two-step linear equations to represent situations. Please make sure as you're watching the video that you are taking good notes. Okay, the first situation says that a savings account has $250 in it. Then X dollars is withdrawn. What is the new total balance Y in the savings account? So with any situation, you want to go ahead and identify your independent and your dependent variables. This problem actually makes it easy for us because it tells us that the X is the dollars that is withdrawn and that Y is the new total balance. So we want to identify X is the money withdrawn, Y is the new balance. Now we need to figure out, is this an additive or a multiplicative relationship? Well, when I'm looking at it, I know that we start with $250 and then we're withdrawing money. This withdrawn means a subtraction operation, right? Which means this is going to be an additive relationship. Remember, additive is when you're adding or subtracting. Multiplicative is when you're multiplying or dividing. So the equation format we are going to use is the y equals x plus b. So let's do it. Remember, when you write your equation, the y and the x will stay y and x. We don't replace them with any number values. So y is going to equal, now we're going to talk about the x. X is being withdrawn. So that means it is negative money, right? So we're going to do it as a negative x plus the $250, because the $250 is positive. That's what you start with. That's one way of writing it. The other way is you could say, okay, y is equal to 250 minus x. That means the same thing. The y and the x remain y and x, and then you've got your additive relationship here. Okay, the next one. Cookies cost 75 cents each. I can already tell this is multiplicative because each means to multiply, right? It helps if you annotate the problem as you read it. So cookies cost 75 cents each, where y represents the total cost of x, which is the number of cookies. All right, independent, dependent. Anytime you're looking for the total of something, that's going to be your dependent, your y value, the total cost. Anytime you have the number of something, that's usually always going to be your independent. X, the number of cookies. And we already said each means to multiply, so it's going to be a multiplicative relationship, which means we're going to use the y equals kx equation format. So let's write it. Y equals y. The k is the coefficient. It's what we're multiplying x by, and we're multiplying it by 75 cents, or 75 hundredths. X. So there's your equation. Not too bad, is it? So now let's talk about two-step equations. So first, the equation that you see here, it shows the cost y of a hamburger with x different numbers of toppings. So you have to identify that independent and dependent. We're looking for cost. This is the total cost of a hamburger. That's your y. And then the number of toppings is your x. So x independent is the number of toppings. The total cost of the hamburger will be your y, your dependent. Now we're going to talk about the initial value, or the y-intercept. Okay, remember that initial value, that y-intercept, it's just a number. So it's our constant. So in our equation, what is the constant? It's the $1.99. And what does that mean? In this situation, that means if you get a hamburger with 0 toppings, it's going to cost $1.99. That's the beginning or the initial amount that you're going to pay for just a plain hamburger. Then in the equation, what is our rate of change? Our rate of change is the coefficient to the x. It's the coefficient. It's that number that you're multiplying with the x. So in our equation, our coefficient is 50 hundredths, or in many terms, 50 cents. What does it mean? It means every topping you get, or each topping you get, is 50 cents. It's 50 cents per topping. That's breaking down the two-step equation and how it's represented with the situation. Okay, very important that you can do that. So let's try another one. The linear relationship below shows the cost y to attend the fair if you ride X number of rides. Again, identify the X, identify the Y. What do they mean? Well, it says the cost of the fare is going to be Y. That's going to be your total. And X is the number of rides. So X is the number of rides. You have to know how many rides you're going to ride to determine the total cost of the fare. Now, what is that initial value? The y-intercept. This is the constant. In our equation, what number is the constant? That's just a number. It's the positive 10. So it's going to be $10 because we're talking the cost of the fare, right? What does that mean? That means you can go to the fair and ride no rides. You can just walk around the fair, take a look, meet friends, talk to them. It's going to cost you $10. That's with no rides. That's just to get into the fair, $10. So C asks you, what is the rate of change? Again, that's our coefficient, right? So our coefficient, looking up here, coefficient is the number that's being multiplied with the X. So our coefficient is $1.75. That's the rate of change. What does that mean? Well, X is the number of rides, right? So this is $1.75 times the number of rides. This is the cost for each ride. It costs $1.75 for each ride. Okay, so now that we've broken that down, let's actually go and try this. Okay, we have the situation. A machine salesperson earns a base salary of $40,000 plus a commission of $300 for every machine he sells. Write an equation that shows the total amount of income the salesperson earns, Y, if he sells X machines in a year. Okay, again, identify the independent, dependent variable. It tells us, it says X machines. So X is going to be our independent, and it represents the number of machines.
Good morning. Will the following...
Okay, and then the dependent is the Y, and that is going to be the income that the salesperson earns. So Y equals total income. Okay, rate of change, y-intercept. The rate of change is going to be what you're multiplying by. The y-intercept is going to be that constant that you're adding or subtracting. So going back through the problem, let's do some more annotation. The salesperson earns a base salary of $40,000 plus a commission of $300 for every machine he sells. Okay, those are the clue words I have. Plus means to add. Okay, every means to multiply. So let's start with the multiplication. That's your rate of change. What are we multiplying by? $300. So the rate of change, your coefficient is 300. Which means what number are you adding? You're adding the base salary of $40,000. And y equals mx plus b or kx plus b. Either one, it's the same thing. That's our equation format. Y stays a y. Y equals the coefficient, our rate of change is 300, x. And then we have our y-intercept, that constant amount, it's a positive, so plus $40,000. So that is your equation. And then it says, okay, what would be the salesperson's total income if he sold 150 machines? Well, this is where you're going to take your equation and you're going to replace X, the number of machines, with 150 and solve it. So Y equals 300 times 150 plus 40,000. So go ahead and pause the video, solve that, and come back to check your work. Okay, did you get $85,000? If you did, great job. If not, just take a look down here. I kind of ran out of room, so I went to the side, but you can see how you should have solved it. Okay, next one. Lynn is tracking the progress of her plant's growth. So again, I'm going to annotate as I read the problem. Today, the plant is 5 centimeters high. the plant grows 1.5 centimeters per day, 1.5 per day. So write a linear equation that represents the height h of the plant after d days. Okay, independent, dependent. We're not given the x and the y. The variables that we're given is h for the height and d for the days. So what do you think is the independent? Is it going to be the total height of the plant, or is it going to be the number of days? The number of days, right? So the independent variable is going to be d, which equals the number of days, which means the dependent, what you're looking for, is going to be h, which is that total height. Okay, rate of change, k. This is your coefficient. This is what you're multiplying by. So going back through my annotations, I see per means to multiply. And what are we multiplying by? 1.5. Then the y-intercept, that's your constant. That's that one time amount, that just a number amount. And that's going to be 5. Today it is 5. That's just a number, positive 5. Now write your equation. Y equals k, the coefficient, 1.5, x, plus your y-intercept, your constant. There you go. Y equals 1.5x plus 5. And then you can answer the question. Once you have the equation, you can answer your question. What will the height of the plant be after 20 days? So you're going to replace d, the number of days, with 20. And I guess I really should have written my equation using the correct variables. It really should have been h equals 1.5d plus 5. Sorry about that. Now I can go and I can replace my d with 20 and have h equals 1.5 times 20 plus 5. So go ahead and solve that and see what you get. Okay, so you should have gotten a total of 35 centimeters. 35 centimeters. The total height after 20 days would be 35 centimeters. Okay, Bobcats, great job.